All right. Happy 311. 3.11. Happy Tuesday? Wednesday. All right, let's get started. 3.11 is all about greatest common factor. Okay. I want you to write a numerator and denominator of each fraction in the prime factor form, then say the greatest of the numerator and the denominator factor to simplify each fraction. So we're not going to do part A. Cause some confusion, but we're going to do part B. So what I want you to do is write it out. So x to the fifth is x times x times x. All 5 times, and y to the seventh is y 7 times. So pause that. I'm going to do the same thing. That's what mine looks like. Okay, a lot of y's, a lot of x's, a lot going on. So what I want you to do now is circle what they have in common. So they both have the top and the bottom both have 2 x's in common, right? And then there are 7 y's in common. See that there's that overlap there. Okay, you can just really see it by looking at the original, but the visual representation is good too. So really our GCF here is what's circled. How many x's do they have in common? They both have at least, the numerator and denominator both share at least 2 x's and 7 y's. So that's our GCF. After we take out that GCF, what's left over? I have 2 x's on top and 3 y's on the bottom. I'm gonna have to pause here. I think we're good. All right, let's keep going. Okay, so like I said before today, do you know the difference between factored and non-factored forms of an expression? Can you find the GCF of the terms of a variable expression without writing the prime factors? All right, so what they mean by that second one is saying, all right, without going through this process, can we get this? Okay, so in our last section, we talked about, solving for variables and things like that. We want to look at here's how to convert the formula to convert Fahrenheit to Celsius is given here. All right, this is considered factored form, right? And this is non-factored form. And why is that? Because if you look, good morning. Right, we're back. So I can tell this is factored form because the GCF is taken out. Here you can see that in the non-factored form, the F has a 5. Technically, so does this one. This one, the factor form, is a lot easier to deal with than because I only have to deal with this fraction once. Notice that when the value in the factor form for 212 is simpler because the fraction. Oh, how about that? I should write the book. Here we go. Let's keep going. Evaluating the factored form, okay, when Fahrenheit is 212, and it shows your work here. All right, here would be a little bit tougher. All right. Let's keep going. Let's maybe try. Let's maybe try some. So factoring is the process of writing a sum or difference as a product. Okay, so if I have 3x plus 6 as the non-factored form, because I can take a greatest common factor of 3 out and write it as 3 times x plus 2. So this number 2 asks us to factor the following formula for the area of a trapezoid in 3 different ways. So which of the following factored forms involved factoring out the GC? So the first way I could do this, well, look, they both have a 1/2. Both terms, our first term and second term, have a 1/2. So I could just take out the 1/2. I have h b1 plus h times b2. Another way I could do this is by just taking out h. H times 1/2 b1 plus 1/2 b2. All right. The third way I could do this, okay, is by taking out both the 1/2 and the h. All right. And saying 1/2 h and then b1 plus b2. Now, of these 3, which of the factor forms involves factoring out the greatest common factor? Well, it's this red one right here. This one does. Why? Because if you look at this blue, both terms inside our parentheses still have an h. All right. If I look at the green, both terms still have a 1/2. So the greatest common factor is the 1/2 h. All right, so there's this next example that looks more at an expression involving x's and y's here. All right, so factor out the greatest common factor. Well, if I look here, the book wrote this out. Excuse me. Wrote it out in this prime factored form like the first one. Okay, so you could easily see what's in common. Now our goal is to be able to skip this step and jump all the way to here. That's our goal. That's our goal for today. We want to be able to write this out without having to do that. Okay, now it seems daunting, but I think we can handle it. All right, you always place your GCF in front of your parentheses so that, like it says here, we can check our work by distributing. If you distribute that GCF and you do not get your original problem, then you know that you did something wrong. Okay. All right. So let's maybe try a couple. All right. So we're looking at number 3. Find the greatest common factor. Well, if I think about, let's just look at the variables first. All right. I can see that both terms have y's. Both terms do not have x's, so x is not going to be involved in our greatest common factor. Well, I want to think about how many y's does each term have, at least. This term has 4. This one has 2. So they both have at least 2. So I can take a y squared out. The next question I got to ask myself, all right, what is the greatest number that goes into 16 and 100? All right, 2 goes into both, but is that the biggest? Well, if I take out a 2, I'll have 8 and 50. I feel like I can take out something else. Okay, what else? I mean, sometimes it may just be a guess and check thing where you sit there with the calculator, 16 divided by 3, or 16 divided by 2, 16 divided by 3, 16 divided by 4. Well, 16 divided by 5, et cetera, et cetera, et cetera. Okay, we know that 4 goes into 16 and 4 goes into 100. So 4 is actually our greatest common factor here. All right, what's left over? I get 4y squared plus 25x to the 5th. Since this second term had 2 y's, right here, there's a y squared, and y squared was my GCF, I will not see a y in that term. Okay? I start with 4 y's. I take 2 away, I have 2 left over. I didn't take any x's out, so x just comes along for the ride. Let's look at part B. Part B is a little bit different. All right, I want to see what number goes into 51, 34, and 68. Well, fortunately for us, there's only one number here. The number is 17. How would I figure that out? Well, I would sit there and do, all right, I would take the smallest number. Okay, our smallest number is 34. Divide that by 2. 34 divided by 2, you get 17. 34, does 34 go on, does 3 go to 34? No. Does 4 go to 34? No. 5 definitely doesn't. So 6 doesn't as well. All right? If 3 and 2 don't, then 6 won't either. Okay. From there, if I know that 17 goes into 34, well, I want to see if 17 goes into 51 and if 17 goes into 68. Okay, and it does. So I know that 17 is part of that GCF. The next thing I want to do is look at my variables. I have YZ, I have YZW, and I have WZ. All right, well, there's a Y in these 2 terms, but not in this third one. There's a W in these 2 terms, but not in this first one. But there is a Z in every single term, so I can take the Z out. And the book only asks you to identify GCF, but we're going to practice factoring it out because we definitely need that practice. All right, so I'm left over with 3y plus 2y, W plus 4w. And all I'm doing here is dividing each term by 17. 51 divided by 17, I get 3. 34 divided by 17, I get 2. 68 divided by 17, I get 4. All right? And then you just cancel out the variables. Let's keep going. For this one, all right, excuse me, the GCF is a little easier to identify. What's our smallest number? Our smallest number is 4. Well, 4 doesn't go into 6. So I know that the GCF has to be 2. Okay, right away. I know that GCF has to be 2. Why? Because 4 does not go into 6. Okay, I can't take a 4 out of 6. I can take a 4 out of 8. I can take a 4 out of 16. I can even take a 4 out of 32. But I cannot take a 4 out of 6. Okay. If you look at your x terms, if you look at your variables, I have an x squared, x to the third, x to the fourth, x to the fifth. Each term has at least one x, and then I sit here and I divide. 6x divided by 2x, 4x squared divided by 2x is 2x. 8x to the third divided by 2x is 4x. 16 divided by 2 is 8. I have 4 x's. I take away 1. I get x cubed. And 32. All right, so now it gives you this how it works. Find the greatest common factor of the terms. This is the product of GCF and the coefficients. Write the GCF in front of the parentheses. Yada, yada, yada. We've just been doing that. All right. Let's keep going. Factor out the GCF of each expression. So, small number is 30. Does 30 go into 75? No, it does not. Okay. Then I want to start off with 30. 30 divided by 2. What is that? That's 15. Okay. I want to think, all right, does 2 go into 75? No. Does 15 go into 75? 15 does go into 75. So our GCF is going to include 15. I want to look at my variables. X squared, x times y, GCF of x. So then I have 2x, 1x is left over. I start with 2. I have 1 left over. I start with 2, take 1 away. There's 1 left, 75. 75 is 5 times 15. The x's cancel out. I'm just left over with y. Is there an easier way to think about these GCFs? Like, how do you figure out that 15 would be the factor? Sure, I could list the factors of 30 like this, and I could say, all right, 2 times 15, 3 times 10, 5 times 6, and then that would be it. 75, I could go, all right, 2, no, 3 times 25, 4, no, 5 times 15. And the moment I see a big factor like this, hey, there's our 15. That's our GCF. That's one way to think about it. All right. If you're having trouble, coming up with the actual number to take out. All right. If I look at B, B is a little bit easier. Okay. What's our smallest number? Our smallest number is 7 here. Okay. 7 goes into 28. 7 goes into 14. Perfect. So our GCF is 7, so we don't have to do all this work over here. I take out a 7. I go to the variables. Each term has at least one W. Each term has at least one Z. So I can take out a Z. 14 divided by 7 is 2. I have X, W, Z, and I take out W, Z. So I'm just left over with X. 28 divided by 7. Keep that minus sign there. That's 4. I have WZ cubed. I take out WZ. I'm left with Z squared. All right. And then I have, these are the exact same. Right? So the common mistake people make is they don't write the last term. All right. They'll write plus 0. Okay. You actually need a placeholder there. And by placeholder, I need to put a 1 there. Why? Because remember at the beginning, we said if you want to check your work and you distribute, if I distribute this, I need to get my original. If I were to just include nothing here, well, a big red flag to us should be, well, I started with 3 terms, 1, 2, 3. Then all of a sudden inside my parentheses, I only have 2 terms. If we start with 3, inside our parentheses must be 3 as well. 1, 2, 3 terms. So in part C, I start with 4 terms. Inside my parentheses, no matter what my GCF is, there must be 4 terms. Okay? All right. Now, what number goes into, does 8 go into 24? Yes. Does 8 go into 12? No. I want to think about, I could do this process here, do that process. I could sit here and say, all right, what are the factors of 24? Well, I got 1 and 24. I got 2 and 12. I got 3 and 8. Keep going. Factors of 8. 1 and 8. 4. Now, this should be a dead giveaway to us that the only factors they share are 8, 2, and 4. I want to be thinking about, all right, it can't be 8. Why? It can't be 8 because 8 doesn't go into 12. So I should be thinking to myself, okay, it can either be 2 or 4. All right, so if I go to 12, I go 1 times 12, 2 times 6, 3 times 4. Well, there's that 4 again. 16. 2 times 8, 4 times 4. Okay, so I see that while they all share a 2 in common, the greatest number they share is 4. So our GCF is 4. I'm going to actually do this on the next page. Our greatest common factor, I said, was 4. And now remember, like I said in the last problem, I have 4 terms, so I need 4 terms inside. 24 divided by 4 is 6. 8 divided by 4 is 2. X comes along. Now, after I forgot to mention this, 24 doesn't have an X or any. Only the greatest common factor is 4. I can't take any X's out. 12 divided by 4 is 3, and that's X cubed. 16 divided by 4 is 4, and that's X to the 5th. Not sure what else I have. I believe we skipped. Yeah, we skipped. I'm skipping number 5. We're going to come back to it when I'm back in class. Because I would be there to talk to you about it. And really, we could probably. Hold on, let me just double check. But I'm going to stop it here. Actually, no, let's just keep going. All right, there's this factor by group. We only got 2 of these problems, so it's not going to be too bad. Factor by grouping, which you talked about last year, for sure. What you're thinking about is you're looking, factor by grouping happens when we have 4 terms, and you factor out the actual GCF, first 2, and the GCF from the second 2, so that once I factor out the GCF, these 2 parentheses match. Okay, if these 2 parentheses match like they highlighted in red for us here, then the actual factored form is just that. All right, let's just take a look at it. So if I look at these 2, all right, factor by group, and I got the first 2 terms and the second 2 terms. These first 2 terms, what's the GCF between x squared and 5x? The GCF is just x. Okay. If I take an x out, I have x plus 5. The GCF between 9x and 45, well, 9 goes into 45, so it's positive 9. And what's left over? I have 5. Well, if you look there, I got x plus 5 appearing twice. That means I win. X plus 5 is one of the factors. The other factor, like I said, that wasn't too bad. I just wait till we get to split the middle term. All right, let's look here. Group the first 2, group the second 2. If I group the first 2, GCF between xy and 11x is just x. And what's left over, I have y plus 11. 10y and 110. Well, it's 10. And what's left over is y plus 11. Well, you can see y plus 11 appears twice, so we won. And then I'm left over with x plus 10. Okay, so your homework today is going to be a little bit different. It's going to be an actual worksheet. All right, I'll post the worksheet. I'll post the problems on Schoology. It'll just be an actual assignment. It just won't be out of the book today. It won't be in the book. Okay. Remember, what's the point? What do we learn? We learn how to factor an expression, use the greatest common factor.